All right, hello, good morning, everybody. Today we're covering radians as a measure of angle. We're going to talk about what they are, how to convert between radians, and the measure of angles we already know, which is degrees. Some applications of radians as our angle measure, and then some good angles to remember, just so you're not reinventing the wheel every time that you're working with these things. So first of all, what is a radian? The definition of it, it's a measure of an angle, and how we measure it is like this. This is how we've defined it. So if you think about the unit circle, that's a circle of a radius 1, right? So its radius is 1, and if I walked that length of the radius, say it's 1 mile, and I walked 1 mile along the outside out here and then hit stop, whatever that angle was, that's what we're calling 1 radian, okay? So it's the angle that traces out the radius on the outside of the circle. Okay, so it's a very different idea, but one that's kind of neat, and it cuts up the circle into a different way. So it's the angle that corresponds to this arc length of 1 on the outside, or the arc length of the radius. That's how much we'd have to turn to get that curved length. All right. As a small nerd note here, and this is not really that important, but maybe for engineers this will be important to you someday, that the radian is a dimensionless measurement. If we look at the arc length formula, which we'll unpack a little bit later, S equals R times theta, where S is the has the dimension of length, radius is the dimension of length, so it doesn't leave us any ability to have the angle have dimension, okay? So I've always thought that's pretty interesting, and it actually comes, again, into play if you are going into engineering, working with things that have circular or wave motion. But let's move on to, now that we know what a radian really is, how can we convert from radians to degrees and back and forth? And then we'll look at some quick applications of that.